Welcome to BKW Physics. I'm Mr. McConley, and today we're going to spend a little bit of time diving into Newton's laws. What does Sir Isaac Newton have to say about this? Now, Newton had several laws, and today we're just going to focus on the first one. So Newton's first law says, an object remains at rest, or it moves with a constant velocity, unless acted upon by an unbalanced force. It's called the law of inertia. So some people immediately think of, oh, that's kind of like, jumping out of a plane. And so when you jump out of a plane, though, are you remaining at rest or moving with a constant velocity?
No.
No, so it must not be like that. So we're going to have to dive more into that idea. It's called the law of inertia. And what you'll learn about inertia is that the more mass you have, the more inertia you have. Now I'm saying you, whatever the object is, whatever the item is that you're talking about, if it has more mass, it has more inertia. It does not matter how fast it's going, it just matters how much mass it has. So if I put the simple example out in front of us here, and on this picture right here, we have a slow-moving dump truck, and we'll assume the dump truck is loaded, it's very heavy. And over here, you have a very fast, tiny little car. Okay? I don't know what that brand is or anything like that, but it's just a tiny little car. And a big, huge dump truck. Which has more inertia? And a lot of you are starting to think, well, the little car is going fast, but it's light, and the big truck is going slow, but it's heavy. And maybe they're kind of equal. That concept that you're locking in your brain is called momentum. We're not doing that right now. We're doing inertia, and inertia is just based on mass. So the answer is
The dump truck.
the dump truck. Simply, the dump truck has more inertia. And this law is going to roll into Newton's second law, but not today. Today we're going to focus a little bit more on some demos that are in the back of the room. And these demos will sort of solidify. Does that work for right there?
That should.
Okay. These demos should solidify the idea of inertia in your mind. The first one, not super interesting. I'm just taking a penny, I'm putting it on top of an index card, and I'm putting the index card on top of a coffee mug. And when I flick it, the index card goes flying away, and the penny... I had another nickel in there. The penny ends up in the bottom of the cup. So you can watch that again. And this time when you watch it, tell me what is demonstrating inertia. Oops, I flipped it poorly. You got to hit it real square. Oop, not like that. See, when the card folds when I hit it, it's not going to work. I got to hit it so that the card... Oops. There you go. You got to hit it square. Lucky I got it the first time, actually, because I usually do it 3 or 4 times before I can get it. So, which thing is demonstrating the inertia? The penny. The index card is moving, and the penny is the thing remaining at rest. Okay? In fact, think of it this way. The index card starts from 0, initial velocity is 0. I hit it, and it has a huge acceleration while my finger's hitting it. So it accelerates and it goes shooting out this way. It flies to the side. During that time, the penny is sitting there, and it doesn't really accelerate hardly at all. It just sits there and then drops. And the reason it sits there and then drops, because it has inertia. Make sense? All right. Now I'm going to take 2 volunteers here. So I got 2 volunteers, and they're going to stand back here, and another really simple demonstration of inertia here. I've tried to choose a pretty big feller and a smaller feller here. And what's going to happen here, this has nothing to do with your manliness or your strength. Okay? This has to do with inertia. Don't stop thinking. It's a physics thing. Okay? So this has to do with inertia. If I have you guys stand, that's a good distance, I guess, and I have you guys put out your hands like this, hands against hands. Now, I don't want you to rearrange your feet or move yourself in any way, but I just want you to steadily push away from each other, and you're trying not to tip over. So go ahead and push. Go ahead and push. And as expected, this guy can't seem to win. Is he weak? Definitely not. He's a strong young man, but, do it again. No matter what he tries to do, this man can just push him over. Thanks, guys. What's that all about? Well, the guy over here had way more inertia. Okay, not making fun, just saying. Way more inertia. So no matter what the guy over here did, the inertia will win. This is why you don't see a lot of football players that are super skinny in the NFL. Because you need some inertia. When you get hit, you need some amount of inertia that will keep you still. Because you don't want to get hit every time and knocked all over the field. You're going to be just beat up. Okay, you need some body mass that's going to keep you there so that when you bump people, you can keep your feet planted on the ground. So that's another demonstration of inertia. The last one that we're going to check out here, a lot of people find quite fun. This is a tablecloth, kind of. Okay? Actually, that's a little big. Let's go. That's better. I got a tablecloth here. There we go. And I got a plate that I'm going to place on the tablecloth. I got to get my physics eye going. Now I'm ready, and I can go like that, and I can pull the tablecloth out from under the plate. Okay? Now, obviously, going with the same trend we've been seeing here, this plate is demonstrating the inertia. It's got some mass to it. It's a real, ceramic plate. Notice the chunk when I have screwed up this demo. So this is a real ceramic plate. It wants to stay still because it's pretty massive. I'm applying a pretty big force and causing an acceleration of the tablecloth, but this thing's got inertia, so it just sits there. Okay? Watch again. I'll even make it more challenging. I'll put the plate closer to the edge. Okay? Oh, that wasn't very good. All right, now, to take it a little bit further, of course, you need your side dish and your mug. Okay? Now, why did that seem easier?
Because you have more inertia.
Because I got more inertia. So some people think it's more challenging to do more plates. It actually becomes easier because it becomes more massive. It doesn't want to move as much, and I can
Just stack them, do it separate.
Now let's do it separate, as one student suggests. So we're going to do something like that. It's a more realistic place setting. Okay? Okay? Not a problem. In fact, the plate moved the most, and I think that's because I kind of pulled it. I kind of did one of these when I pulled it. You got to pull it pretty straight. Okay? So this is a demonstration of inertia for today.